This is May-June 2024, P12. The first question suggests what the micrometer can be used for. So micrometer is device for length. That is a pretty straightforward question. Moving on to the next part is question number 2. Two people pull the ropes to move the boat along a canal. So one of them is exerting a force in this direction and one of them exerting a force in this direction. Probably the resultant would be somewhat in this direction. He says the boat moves with a constant velocity, which means that the resultant force by the people, or by the person standing on two sides, the two people standing on the sides, would be equal, or the resultant should be equal in this direction in terms of drag or in terms of any other forces that are influencing the boat. So the vector diagram of the tension is shown, which is evident from the diagram itself. He says which diagram is the drag acting on the boat. You see, you might be mistaken by this question in terms of situation B. B is the wrong answer because you might not read this carefully. You may assume that the question would ask you, due to past paper practice, about the resultant, which would be B. But he's asking about the drag, which means that according to Newton's second law, if there is a force, let's say there is a resultant force in this direction, and if it is moving at a constant speed, which means the acceleration is zero, there will be a backward force of drag or friction or the combined effect of both of them, and they will be equal to each other because it's moving at a constant velocity. A very basic principle of second law, or Newton's second law. So if we want to look at drag, that should be option A, and it wouldn't be B. Question number 3. It suggests that there are 3 sections and it's a speed time graph. First thing you need to remember is that the gradient of the speed time graph represents acceleration, or be that for the velocity time graph, it represents acceleration, and the area under the graph represents the distance traveled. For velocity time graph, the area would represent the displacement. In this question, it says, where does it show the largest acceleration? Now, since we understand that acceleration is the gradient, we are looking for the largest gradient or the largest slope. So first, let's identify where the slopey regions do exist. So there is a region A, there's a region B, and there is a region D, where we can see that there is a slope. There is a slanting of the line. So which one or which section shows the largest gradient, largest slope? Although D covers a longer period of time, it looks lengthy, right? But we can see that the gradient or the maximum steepness exists in section A. So option A will be the right answer for this question. Next question is question number 4. It suggests that this is a very basic common question in terms of at least the lessons we conduct in the classrooms. He says that a student or a person moves from X to Y in the path shown in the diagram below. A man measures the distance he walks and the time taken he walks, right? So we have some distance and we have some time taken for the process. So I understand this would be either speed or it can give us the information about velocity. But let's see. So which quantity can be calculated using the data only? So can we calculate acceleration? No. Acceleration involves a change of speed. We don't know what the speeds were at different intervals of time. Then average speed. Yes, this looks like a plausible answer, but let's move on to the next question. Next answer. Average velocity. We could have done this if it had been in a single direction because velocity requires displacement. Since it's not, the direction is changing again and again. This implies that this is about distance. Since it's about distance and we have the time taken, it can only be about speed. Now, since he's talking about the total time taken, right? So there will be an information about average or the involvement of average term because average requires the total distance divided by total time. This, again, power has no meaning over here. That is the amount of energy or the work done divided by time taken. There is nothing of that sort or mention, at least over here. So the option B seems to be the right answer. In question number 5, we have which property of the object determines the resistance to change state of motion. Again, this is exactly the definition of mass. And this concept or the idea is actually inertia. So question number 5 is actually a straightforward answer, directly picked from the syllabus. If you have read the syllabus, you will see that this is exactly the statement made for inertia, which concludes to mass. Question number 6, he suggests that the diagram shows a moon buggy used by the astronauts. And he says that the mass of the moon buggy on the Earth is 210. Now, be that the mass on the Earth or be that the mass on the moon, the mass does not change. That is what we know about it, because mass is the number of atoms or the quantity of particles inside an object. So the number of atoms that make up this buggy, definitely they will not be changing. The gravitational field strength on the moon is 1/6 of the Earth. Okay, so if the gravitational field strength of the Earth is 9.8 according to the new syllabus, then we can find the weight. That would be mg. Mass, since it doesn't change, that will be 210, and g, which is 9.8, but since you're on the moon, it is actually 1/6, or at least divided by 6 of the new scenario. So weight over here will come out as, if you calculate them, this will come out as 340. This is 340 newtons. Please remember that it is not 10 anymore. It's going to be 9.8. Although it doesn't make a difference if you solve this with 10, because there is a very large difference with the next possible option, but still, for the sake of practice and subconsciously making the right choice, it would be a good idea to choose it this way, right? Of course, there will be a decimal answer, but sub to two significant figures, it will still be D. So we've done question number 6. Let's move to question number 7. Again, from the Newton's second law, this question looks influenced. So a car traveling along a straight line, there is a force of 800 newtons from the engine. The motion of the car depends on the value of R. Definitely. He says which row describes the motion of the car for the value of R. Now, very simply put, according to Newton's second law, if this is the forward force, then the resultant force, or let's call this Fr, is equal to 800 minus the the resistance or the drag or the friction, or the combined resistance produced by the drag or the friction. This will determine the resultant and then will be equated to MA. Now, if 800 is equal to R, only then the acceleration is 0, and the object moves at a constant speed, right? It will be constant speed. If 800 is greater than R, then the acceleration will be greater than 0, and it accelerates or speeds up. If 800 is less than R, or R dominates, then definitely acceleration will be less than 0 or in negative, which will be a case of deceleration. So these are the only 3 cases that can exist for the Newton's second law. He says which row describes the correct case. So we can see very clearly over here that if R is 500, if this is 500, then the forward force is greater. It should have been acceleration. So this is the wrong answer. If it had been B, let's say if it was 800 newtons, then both forces are equal to each other. It should have produced no acceleration or deceleration. Option C says 900 in the backward direction, which is again R being greater than the forward force. So there should be deceleration. So this looks like a plausible case. In option D, he says 1000 in the backwards direction. So again, 1000, which is R, is much greater than 800. So it should have been deceleration. It should have been deceleration, then it would be the right answer, but it's not. So C seems to be the right answer. Let's move on to the next question. He says question number 8, again, a very common and a repeated question. This is a very repeated question in terms of Newton's third law. Let's draw all the forces and identify what parts of the solar system are involved in this question. So we have a sun, we have the earth, and we have the moon, right? So this is the sun. For simplicity, this is the sun, and this is the earth, and this is the moon. Now let's make all the forces that he's mentioned. So first, force P is on the moon due to the earth. So on the moon due to the earth, that is force P. Then the earth and the moon identifying as R is on earth due to the moon. So this will be R in this direction, according to Newton's third law and law of gravitation. Q suggests earth due to the sun. So that would be in this direction. This should be Q. And then S is the force on the moon due to the sun. So S will be from the sun. Let me choose a different color for this. So S will be from the moon towards the sun, right? S. So which one of them represents the Newton's third law pair? You see, for S, there should be a counter S, according to Newton's third law. And if there is a Q, there should be a counter Q as well, which they do exist. We're not ignoring the fact that they don't. They do exist, but he hasn't mentioned them in the question, which means that I cannot accept S and Q as a part of the Newton's third law, because they should have been mentioned as pairs like this. The only pair that is mentioned which can be successfully selected for the Newton's third law is a pair between the moon and the earth, which is P and R, right? So question number 8 would have an answer of B as P and R. Question number 9 again is a repeated question from past papers. He says that the box is rough box, which means that the friction will exist from X to Y. And since it says it is from X to Y, that means the box is moving in this direction. So A would become the driving force, and C would become the friction force. B would become the weight, as we've done from our lessons, and D would become the normal reaction force from any surface perpendicular to it, if an object is placed on it. Now he says which force is due to the friction, which is very clearly option C. Now let's say if the box had been moving downwards on its own weight, then the friction would be opposite to this one, since friction always opposes motion, right? Okay, question number 10. He says, again, this is a repeated question. It is exactly the same question as I've seen in the past papers previous years. He says that the graph shows how the extension of 4 different threads depends on the load attached. Which thread is most difficult to stretch over the range of loads shown? You see, most difficult would mean that by the extension principle, which is force is proportional to extension, or EK or KE as Hooke's law suggests. So force is proportional to extension. Most difficult to stretch would mean that you apply a very high force, but it changes shape very little, or a very little change of shape is experienced. You apply a lot of force, but nothing happens, right? So another thing to keep an eye over here is that he has exchanged the load and extension graphs or changed their location. Normally, when you do this in the classroom, you see that force is on the y-axis and extension is on the x-axis, but he's swapped the graph. So a good idea would be to check this by point analysis. Now pick any force that you want. For example, let's choose this force. Let's say that for the sake of example, this is 20 newtons. Let's say this is 10 newtons. So if we look at 20 newtons, the D strand stretches by this value. The C strand stretches by this value for the same amount of force. Similarly, B strand stretches this much, and A has almost, let's say, stretched up to this point. We can see that the extension value increasing from 1, this is 1, this is 3, this is 5, and let's say this is 7. It's increasing. For the same amount of force, option D has stretched the least amount, which means that it would be most difficult to stretch. It is the most difficult to stretch across this range of loads. So option D would be the right answer for question number 10. Question number 11 was the tricky one this year. You see, for the question involving circular motion, the students have practiced that in quick succession, this is from a circular motion question topic, in quick succession, they would look at the question and just mark B and be done with this. They wouldn't even spend time reading the question. And I'm sure the examiner will mention this in the examiner scheme, examiner report, that this year student mentioned B but didn't read the question carefully. Now, what's wrong with the question? What's different this year? You see, the rest of the question is exactly the same. He says there is a force on the satellite due to the planet. We understand that. Now, this B force is because of the satellite. Now, this B is because of the satellite on the planet, which is fine. There will be a force in this direction. Again, this would be by the satellite on, this will be by the planet on the satellite. According to Newton's third law, exactly the same question we've done over here in question number, sorry, I may have missed it, in question number 8. 8 is being repeated in question number 11 in parts with the circular motion. You see, he's asking you that in which direction force on the satellite when it is in the position shown, right? So on the satellite is actually in this direction, but that direction is not shown with respect to the satellite itself. Rather, it has been displaced from this location and drawn at this location, right? We understand that we can move around vectors in a free body diagram at our ease for the head to tail rule, So what he did this year, you might have mistakenly marked this as option B because of the past papers previously done, but this time it was option D, right? I understand that you might have known the concept yourself, but since you didn't read the question, or some of you may have missed the question because of the bias you've already set in your head, you might have mismarked this question. Question number 12. A crank has, now this is a classic question from moment and forces, or clockwise or anti-clockwise movement. He says we want to find out the distance, how far away it is from the pivot. So this point lies as a pivot. The whole system rotates around this pivot. This is going to be the anti-clockwise moment. This is going to be the clockwise moment. And around the pivot, we can put an equal to sign. So this will be simply force of this magnitude multiply its distance or perpendicular distance from the force up to the pivot, which is 2.3. Then there will be an equals to sign around the pivot, around the point where the whole system rotates, mathematically speaking, being equal to the clockwise moment, which is 2300. But we don't know how far away that distance is, how far away it is from the pivot to be able to stay in an equilibrium position. So has he mentioned equilibrium? No, he hasn't, but he has mentioned that there is no moment about P. There is no rotation about P, which suggests that the system is in equilibrium. So then 2300 newtons of force multiplied by distance D. When you solve this D is going to come out as, this is question number 12, this will come out as option C, right? So this is 5.8. The next question is question number 13 from the chapter of momentum. He says the mass is this. It travels at 400 meters at a speed of this, then accelerates to 35 meters per second, travels a further 400 meters. He says a change in momentum. Is this distance or the distance covered relevant to this question? It's not. This value has only been given to you to confuse you. Okay? Now we understand that the momentum formula only involves mass and velocity. If you're looking for change in momentum, that would be final momentum minus the initial momentum. Since the mass is not changing, we can take mass common on the outside, and this becomes V minus U. Now, mass, very conveniently, is already in kg, so this will be 750 into change in velocity, which is from 25 to 35. So this will be final velocity minus initial velocity. You could have put in the values at this stage or at this stage, whatever is convenient for you, whatever you feel comfortable with, that's your choice. Now, one thing I would like to add over here, they are still moving in the same direction. It travels further in this same direction, which means that if the object had a speed of 25 meters per second previously, today it has a speed of 35 meters per second, but they are moving in the same direction. It has gained speed in the same direction. For example, if the object had collided with a wall at 25 meters per second and bounced back with a speed of 35 meters per second, then this velocity would have been considered as positive and this one would have been considered as negative, which would lead to a situation in which V minus U actually yields minus 35 minus 25, which results them being actually added, becoming minus 60. So in the case of bouncing back, you have to keep an eye on this. But this question is very straightforward, so this comes out as 7,500, which is option A, very conveniently. Question number 14 is suggesting that there is, again, this question is from kinetic energy and gravitational potential energy, repeated question. He's asked the question in the reverse order. Usually we find the speed of landing or the speed before collision. Here, this time he has given you the speed, but he's only asking you about the height, that if the fall speed is 14 meters per second, then how high above the building must have been from which the object has been dropped. So the air is negligible. Okay, thank you. So let's put an image to this. So this is the building. This is the vertical height from which the object has been thrown. So previously the object has gravitational potential energy. When it bounces or when it actually reaches the ground, it has converted into kinetic energy, which means that the gravitational potential is equal to the kinetic energy. Putting in the formula, this gives us mgh equals to half mv squared. This helps us to understand that the mass is irrelevant in the situation. We want to find the value of h. So let's take g over here. So this becomes v squared divided by 2 into g equals to h. Now let's put in the values. We have 14 meters per second. This will be 14 squared divided by 2 into 9.8 equals to h, which comes out as 9.9 probably 9.98, which of course up to 1 or 2 significant figures becomes option B. Now, one thing which you could have done over here is that if you were unable to reverse engineer the question, what you might have been able to do is solve the question as the remembered or the memorized formula that you already have from the previous lessons or the classes you may have taken as V equals to 2 under root 2GH, which of course is formulated from this formula. This is rearranged formula in this format. You may have memorized this. What you could have done is you could have opted, or you could have put all the options, some in the first option, try A as 2, try H as 2.9, then try H as 10, then as 20, and then as 40. Put all the options one by one, and only at option B you will find that the answer of V comes out as 13.9 something, which is of course 14. So this is a heated trial method. This is a trick you can use up to your sleeves, right? 15, which energy source is available constantly over a period of 24 hours? Natural gas seems to be, because of course it comes from the Earth's crust. We can access it any much or however much we want. Solar only is available during the day. Tidal is again comes from the sea waves, comes from the fact that there is land breeze and sea breeze. Air moves from land to air and land to air, and then to the sea, and then sea back to the land. So again, it depends on the temperature, depends on if it is present or not. So it's not 24 hours. Wind again is subjective to the conditions of the area itself. So again, it is not available 24 hours. Only natural gas, coal or petrol or diesel would be available for a 24-hour period because we can use it by pumping it out of the Earth's crust. Question number 16 suggests there is a 15-watt lamp turned for 30 minutes, wastes 7,000 joules of energy. What is the efficiency of the lamp? So first, always draw this diagram for an efficiency question. Makes it easy. You see, whatever input energy we are giving, we don't know that today. Whatever output we are getting, there is always two output of the system, output 1 and output 2. Output 1 is generally called as the useful output because this is what the machine was designed to do. Output 2 is generally labeled as the wasted output because you didn't design the machine to do it, but it is doing nonetheless because of its inherent problem. He says it wastes 7,000 joules, which means that the wasted energy is 7,000. But how much is the useful output? We don't know that. So can we figure out something else? Yes, we can. Because he says that it uses 15 watts for 30 minutes, which means that this is actually the input power or the input energy or the energy taken by the lamp. So can we find it? Yes, we can find it. It's very easy because the formula for power is equal to energy divided by time. Now, why can't we use 15 watts directly for the question? You see, the question gives 1 unit of joules. You can either convert the joules by dividing it with 30 minutes into seconds into power and then use the question, or you can convert all the units into a single unit and then use the formula for efficiency. So power was 15 watts. Energy, we don't know. It was turned on for 30 minutes, which is 30 into 60. Bring this over here. So the energy comes out as probably, let me just figure this out for you. So this is 15 multiplied by 30 multiplied by 60. This is 27,000. So this comes out as 27K. So the machine is taking in 27,000 joules of energy. Some of it is being wasted as heat, probably, right? And some of that portion is going straight to the useful output as 20,000 joules. So you provided 27,000, the machine wasted 7,000, and you're left with 20,000. So the efficiency formula suggests the useful divided by the total. What you get back divided by what you spent, 27,000, multiplied by 100 for a percentage, and if not, we can see there's a decimal directly. So this answer would yield you 0.74, which is option D. So question number 16 is option D. Moving on to question number 17, which quantity does not has a joule unit? So mgh also has a unit of joules. Latent heat, of course, Q equals to ml also has a unit of joules, right? Power has a unit of watts. This is most likely going to be the answer. Work done or energy is represented in joules. So C is the right answer. 18 suggests what description of the liquid is correct. Of course, we understand that it doesn't have a fixed shape. So A and B cannot be possible. So it has a variable shape. Yes. It has a fixed volume. No. So it would be, yes, it has a fixed volume. Yes, the volume is fixed. Variable volume, no. So this is why the answer of this question would be C. But can we figure out which of them is solid, liquid, and gas? So fixed shape and fixed volume is a solid. Fixed shape, variable volume, we have nothing of that sort, probably, right? And this is your liquid. And variable shape, variable volume is gas. Question number 19 is from Brownian motion and diffusion of general gases, right? The brown gas and colorless gas, he says that the wall is removed and they are left for a long time, which means the gases can mix together. The gases do not react, of course. Reaction may produce a third byproduct, which may have a different color. So this is why he says that ignore the chemical aspect, ignore the chemistry of this question. Just figure out, focus on the physics of the question of their movement or particle behavior. So what's going to happen? What is seen in the box after the long time? The brown gas on the right side, no, this is not going to happen. The gas is going to mix the pale brown gas throughout. Yes, it feels like that this would be the right answer. Several distant clouds, no. What he's trying to say is that there is going to be clouds lumped together in different parts of the system where the brown gas may be seen, but no. Colorless gas on the right side, no. They are not exchanging positions. They're actually mixing with each other. That is what happens when you put on perfume, or let's say if you put on perfume on one end of the room, it diffuses and travels along throughout the room, so you can feel its presence. It's going to be option B. Very simple chemistry question of diffusion for gases. Question number 20 suggests a bottle containing cold liquid placed on the table on the warm day. Drops of water forms on the outside, which is a very simple process of condensation. We understand that. Question number 21. What is the specific latent heat of specific heat capacity of a liquid? Specific would mean that there is going to be a word of kg. At least 1 kg word will be a part of the definition. And since it's the heat capacity, then there will be 1 degree centigrade of change as well. So this is going to be Q equals to MC delta T. We're looking for something like that. So difference between, no, this is not the definition. B suggests the energy required to change, no. 1 kg is good for specific, but there needs to be a 1 degree centigrade missing in the definition as well. The energy required to heat 1 kg of liquid through 1, yes, this is the most appropriate one. The increase in temperature, no, not just the increase in temperature. We're looking for the full mass, heat capacity, and the temperature. So mentioning mass is necessary and mentioning temperature is necessary, that there is 1 kg of mass going through a change of 1 degree centigrade. Only then we can talk about the specific heat capacity, because then C becoming the subject of the formula becomes something like this, right? So how much energy is spent for 1 kg to raise its 1 degree centigrade temperature? That is specific heat capacity. So 21 is going to be option C. 22 suggests the statement about infrared radiation is correct. In vacuum, it travels speed of light. Yes, all electromagnetic spectrum from gamma up to radio, all inclusive, travel at the speed of light, which is 3 into 10 raised to power 8 meters per second, if they are in vacuum. Radiation, no, it's a transverse wave. Sound waves are longitudinal waves. Infrared radiation has a higher frequency. No, ultraviolet have a higher frequency because they're higher up in the range. White surfaces are better. Again, an inherently wrong statement. White surfaces are poor emitters and poor absorbers. So the best answer is going to be option A. Question number 23. The speed of sound is 330, which sound is classified as ultrasound. So ultrasound are those waves in which the frequency is greater than 20,000 hertz. So what you could have done over here in this question is that 330, the human audible range, would have been F lambda, right? So lambda would have been equal to 330 divided by the 20 hertz signal. Then lambda is equal to 330 divided by the 20,000 hertz signal. None of them falls in this category, right? So anything higher than this, the answer keeps on reducing and reducing, which is not even in option A, B, and C. So it's none of the above. It's the first time that the question I've seen in which an option is given that is none of the above. So please be careful. Don't forget about the centimeter conversion. These answers will give you sometimes an answer in millimeters, sometimes an answer in centimeters. So please make sure that you're using the right unit. Question number 24 is from Light and Lenses chapter, correction of the normal eye behavior. It says a distant object, which means that the light rays have to be parallel before they enter the lens. So in all the situation, we can see that the light rays are parallel, representing that the rays are coming from a distant object. Okay, fine. Since normal eye has to be incorporated, the image or the focus point should be on the retina. Over here, we can see that the focus point is not located on the retina, rather it is behind the retina, and the focus point over here is before the retina or in front of the retina. it should be on the retina exactly. So this point where it focuses on a single point seems to be the right answer. They're focusing on a single point for a normal eye. This is inherently wrong. It's not possible that the light rays pass straight through. Question number 25. He says, again, a question from memory. We understand that the wavelength of violet or blue light is actually approximately 400 nanometers. And as we go down, the wavelength of red light is 700 nanometers. I've advised the students many times over. It's always a good idea to remember these wavelengths. Apart from the wavelengths memorized for the electromagnetic spectrum, the question is repeated almost every year, where he invokes the idea that do the students remember about the wavelengths individually. So question number 25 is very obviously option A. Again, starting from increasing, of course, this is 700 and this is probably 450 because violet, after violet, we see the blue color. Blue color is 450. There is a difference of 50 nanometers in at every stage of the rainbow. So 26 is a thin converging lens is used to magnify glass, which row gives the nature of the image produced and an expression that is the linear magnification. You see, linear magnification has a very simple formula, right? It's always going to be the height of the image, what is being formed, so image height divided by the object height or the length. Of course, if this is the question, let's say this is your object and this is your image, then this is the height that we're talking about, which is mentioned as length in this question, which is fine. It's okay. Now, since we're dealing with a magnifying glass, right? So let's say this is the focal point. This is your object. This is your place of eye. The light rays cannot converge right in front of or on the other side of the lens. So they have to be extended in the backside like this by dotted lines. And wherever they meet now, this is the image that is observed to the person. This is how the magnifying glass works, right? So this image is virtual. It's not real. For real, the image has to be on the opposite side of the lens. If this is the object, this is supposed to be the image. So it's virtual, and it's not the object length. It's supposed to be the image length. So option C would be the right answer for 26. Question number 27. What is not the use of ultrasound? It cleans jewelry, yes. Scanning of an unborn baby, yes. Sonar for the submarines to detect how far the flow or a seabed is. Sterilizing water, no. This does not have a medicinal use like this one, or for at least antibacterial action. Question number 28. Which equation is correct for potential difference? Which is very simple. Voltage is equal to work done by charge. The easiest one of the one to pick out of this one, if you remember the definitions, is going to be option C. Very straightforward. Work done by charge. Again, it's picked directly from the book, directly from the syllabus. Nothing to worry about this. Over here. So question number 29 suggests identical resistor, 5 circuits, and identical. This makes the question a bit easier to understand because then we can use the tricks over them. So he's asking us which of the circuits must have the equal resistance. We can identify that over here the resistors in circuit 1 are connected in parallel. So this is R and R. Now we understand by the tricks that if you connect two identical resistors, they equate to just R by 2. For example, if this is 10 ohms, this is 10 ohms, their combined resistance will be 5 ohms. If you're not convinced with this example, what you can do is you can try to imagine that if this was 10 ohms connected in parallel, this will be 1 over 10 plus 1 over 10 over 1 over R. When you will be done solving this question after the reciprocal and everything else, your answer will come out as 5 ohms. You can try this for any other fraction as well. Let's say if you have 20 ohms resistor in parallels, this 1 over 20 plus 1 over 20 equals to 1 over R. This will become R equals to 10 ohms. I don't even have to solve this. The trick and the guess is that if identical resistors are connected in parallel, they will be halved, but there needs to be only 2 resistors. If, let's continue the trick, if there were 3 resistors and they are identical, let's say this is R, R and R, the total resistance after using the plus 1 over R, plus 1 over R, plus 1 over R would come out as 1 over 3R. So we understand this already, that if they are identical, they will be halved. If they are identical in 3, they will be R by 3, or 10 divided by 3, or 20 divided by 3. Similarly, we can see that in option 2, they are exactly connected in parallel as well. So this will be R by 2 in combination. In circuit 3 also, make sure that the circuit is in parallel. So this will be R by 2. In this, we can see that this is going to be 2R because the circuit is connected in series. There is only one path for the current to follow through. And in option 5, we can see the current again divides into two branches. So when it arrives over here, it can go through this and it can go through this, again calling for a parallel circuit. This will again be R by 2. And before going to the battery, they again combine together at this junction, which again strengthens the concept or idea that this is also in parallel. So what he was testing in the question is that, can you identify the different shapes of the question may mean the same thing? So 1, 2, 3, and 5 are exactly the same circuits connected in a different way, right? So of course they will have equal resistances. So option A will be the right answer. That 1, 2, 3, and 5 have the resistance of R by 2, and only 4 has the resistance of 2R. Question number 30 suggests which electrical appliance uses heating effect of the electricity. You see, this is a good question in terms of understanding efficiency. You need to understand which device was designed for what purpose. Now, you might have experienced that when you're using your mobile phone, when you're playing games on it, let's say if you're doing heavy tasks on your mobile phone, or when you're charging it especially, it heats up, right? Now, you need to ask yourself a question. Was it designed to heat up? No, it's not. Its design is to do something else, to produce colors on the screen, to give you options, or to, let's say you want to do some task, you want to write an email. That is what it was designed to do. It's not designed to produce heat. So heating effect is not the primary concern or the primary output for which mobile phones exist. Although they do produce heat, but this is not what they were designed for. This is what he's asking you in the question. And this is what efficiency is all about. Do I count the heat energy coming from the phone when I'm understanding its efficiency? I don't need to. It's a wasted output. Again, a fan. A fan does produce heat when it is being used for a very long amount of time. But was it designed to do so? No, it was not. So again, this is not the purpose of the fan. A hairdryer, yes. A hairdryer generally is designed to produce a lot of heat so that it can remove the moisture from your hair in a quick fashion. So definitely C is one of the appliances with heating intent in mind. Option D, a lawnmower. Again, it could be driven by a petrol or a diesel generator. It could be driven by an electric motor on a battery. All motors produce electric heat. All motors produce a lot of heat. But what is it their purpose to produce heat? They are not intended to produce heat, but due to the friction of the internal parts, they do. We can't control them. We can reduce them. So again, this was not its intended purpose, but it does so. So option C is the right answer, keeping in mind with the thought that it is designed to produce heat. Not as a byproduct, but as a primary product. So 31, how many kilowatt hours of energy are used by 1000 watts of heater, 230 watts of supply for 30 minutes? Now understand that this 230 volts is just a distraction to sway you into a different direction of calculating the energy. Well, you will get the same answer if you just pay attention to the power and the time spent. If you want to find the energy in kilowatt hours, you need to make sure that the power is in kilowatts. So 1000 divided by 1000, we can do this just by mental math. This will come out as 1 kilowatts of power, and the time has to be in hours, which will be 30 divided by 60, because we understand if you have to go from minutes to hours, we have to divide this with 60. So this comes out as, at least this answer is 0.5. So 0.5 multiplied by 1 is 0.5. So question number 31's answer comes out as option B. Simple, straightforward. 2 and 30 is a distraction. 32. It suggests that which safety precaution should be taken for the electric kettle that has a stainless steel. Now, if the body is of metal, there needs to be an earth wire. So in the question, he says in option C and D, it does not need to be earthed. These options will be rejected to begin with because metal body needs an earthing connection. So it must be earthed, yes, a good practice. Have a fuse in the live wire, yes. Have a fuse in the neutral. We need a fuse, but we don't need this in the neutral wire. It has to be in the live wire. So the best option is connecting in option A, that let's say this is live connection, this is neutral connection. We need to have a fuse before it goes to the appliance. Let's add a switch over here. This is the appliance, let's say, and goes to neutral. And the earth wire has to be connected to the metal body and then grounded. This is the perfect connection, right? A fuse in the live wire and the metal body grounded. If it had been a plastic body, then of course earth wire can be eliminated. That is a double insulation case. What is the purpose of the earth wire plugged again? We just discussed earth wire. Let's see what he's asking us. Connected to an appliance. So complete the circuit. No, it can work without the earth wire. It doesn't matter. That's why you will see that some appliances have a shoe or have a socket like this in which there are only 2 pins. One is for the live, one is for the neutral, and the whatever appliance it is connected to works really well. It doesn't matter. But the third pin is for the earth connection. It has to be there for this maximum safety. To conduct thermal energy, no. It is for to carry out the extra current if it generally gets connected to the live part of the body. To prevent an electric shock, yes, this is why it's here. To protect the appliance, no. Protecting the appliance is not the primary purpose. The primary purpose is to save human life. Then, if we are able to design a good protection for the human life, then of course the second priority would be to save the appliance. So to prevent a person getting electric shock, yes, 33 will be option C. And how can that happen? Let's go back to the circuit. You see, accidentally over the passage of time, since you're using the appliance, you're moving the wires again and again, it's possible that the live wire's insulation gets damaged and gets connected to the metal part of the appliance itself. If that happens, the person who's operating the machine doesn't know that. He thinks that everything is fine, right? If this has happened internally, which is not visible on the outside, the person is under the impression that everything is all right. And if they come in contact with the metal part of the machine, they will be in direct contact with the live part of the circuit, which means that they will get an electric shock and electric current will flow through the body into the ground. This is what we want to prevent. That is why the earth wire exists, because what happens is that if this accident or this malfunction internally does happen, the live wire does come in contact with the metal body because of the internal damaged insulation. The moment you turn on the switch, the circuit looks like this, that the current will not flow through the appliance, rather it will follow a smaller path of lesser resistance and go through the ground. The ground wire has a lower resistance than the appliance itself. The current prefers that path, and the current amount is very high because it's a low resistance path. And according to V equals to IR, we can see that I equals to V divided by R. When the resistance decreases, even for the same voltage, the current will be very high. This is what we're looking for. If the current is very high, this fuse will melt. This is why we have intentionally put a fuse over here. We want the fuse to get damaged so that it breaks apart, it blows over, and the circuit breaks from this point onwards. So in an event where this happens, you might just feel a slight shock if the fuse hasn't given away, and then the fuse will blow again. So 33 is option C. Question number 34 is a bit tricky. The position of the hand will be a bit tricky. He says that there is a current wire, there is a magnetic field. What's the direction of the force? You see, first you will align your finger in this direction according to the magnetic field, which is going to be towards the right side. But of course, please be advised, you have to use your left hand for this. Now, of course, the second finger should be pointing upwards, but due to the awkward angle of the camera, I was unable to take a picture in that scenario. So the second finger represents the current. It has to go upwards. So it's going upwards like this, right? For the second finger. Once you've done that, you will realize that the thumb automatically opens in the downwards direction, right? Which means that the force on the conductor is actually downwards, which is not to the left and not to the right. In 3 dimensions, it is going to be pushed downwards, which is into the page. So 34 is option C. Question number 35 is a call to memory. He says this is a DC motor. We can see that because of split rings. He says, what is the name of the part labeled as Q, which is split rings? Question number 36, diagram for the transformer. Again, I see theoretical statements. I can understand that he was going to ask me about how the transformer works. These statements are exactly copied from the marking scheme of P2. And I've advised the students many times just to memorize that answer. He's going to ask you the question about the transformer. Don't miss out on it. So he says that there is an alternating voltage in the primary coil. Good, induces an unchanging. No, there is always a changing magnetic field or a changing voltage across the secondary side as well. So alternating on the primary, changing magnetic field. Good. In the core, yes. A changing magnetic field, yes. In the core, induces alternating voltage, yes. Across the secondary coil, yes. So option 2 and 3 are the correct answers. An unchanging voltage, no, the voltage is changing because the device works on an AC supply. So you provide AC and you get AC. Now you can see that this is a step down transformer, which means that the voltage will be lower. So if let's say this is 230 volts, this would, due to less number of turns, this probably would be 15 volts, plus minus 15 volts, right? So it's a step down transformer just by looking at the number of turns there are. And this is how it works. So point number 2 and 3 are the correct answer. So 36 has option C. And I would advise you to remember point number 3 and point number 2 and 3 in order. First point number 2, then point number 3 for a P2 question asking you about the working of a transformer. Question number 37 requires which part smallest mass. So alpha particle is actually 4-2. So this has 2 protons and 2 neutrons, quite a big particle. Electron is just the mass of electron, which is approximately 2000 times lighter than any proton or any neutron. So it seems it's the smallest particle. Neutron again has its own mass, proton also has its own mass. So only 2000 times lighter is the electron, and the heaviest of the bunch will be alpha particle, if the question was asked. Question 38 requires the definition of isotope, and we have memorized this in chemistry and physics alike again and again. Same protons but different neutrons. So let's figure out which one of them have same protons. So 14 and 14 are same protons but different neutrons. Neutrons are 22 and 24. So atom 2 and atom 4 should be isotopes of each other. So it's going to be 38C. 39 suggests 4 types of ionized radiation exists. Yes, alpha, beta, and X-ray and gamma. Which radiation comes from the unstable nuclei? Now, radiation from an unstable nucleus or radioactivity itself is only of 3 types. From a spontaneous nucleus, there can be only 3 radiations. There could be alpha, there could be beta, and there could be gamma. X-ray is made artificially by using the X-ray machines, right? Although we can detect a very weak X-ray because there is a switch between gamma and X-ray. There is you can say, there is an ambiguous boundary between gammas and X-ray. Some scientists consider gammas to be much higher than a certain threshold. Some consider them to be even, you can say, going towards the X-ray. There is a thin line, or there is a biased boundary between the ranges. So X-rays, although may come from an isotope, but they will still be categorized as gamma because that is how ionizing they are. X-rays generally do come from an artificial method, right? So he says which could be because of the unstable nucleus. So there are only 3 options. X-ray is not one of them. Question number 40 is, what is the nuclear reaction that powers the sun? Repeated question many times. It's not the fission. Fission is what we do of uranium to make electricity. But in 40, we have fusion of hydrogen, yes, into helium. Yes, helium is not going to convert into hydrogen. It's hydrogen converting to helium.